CUA 9 retake. Number 1. Calculate the length of AB. So since there are no angles that are marked except for the 90-degree angle, we can safely use Pythagorean theorem. That would be the hypotenuse, or C. That would be side A, that would be side B. We could use the traditional form of the Pythagorean theorem, or we could use one of the shortcuts. Oops. Since C is the one that is missing, we're going to use the C. Golly, I keep hitting the wrong thing. We're going to use the C equals shortcut. Here we go. The C equals shortcut. So that would be A squared minus B squared. And we already know both of those numbers, so let's just go ahead and plug them in. So A is 12 squared, and then B squared will be 8 squared. And then let's just plug it into our calculator. That's my calculator. There it is. That'll be 14.4. And I'll just put that to the hundreds place instead of the tenths place. Go ahead and try number 2. Number 3, Jackie is standing 83 meters from the base of the Empire State Building. The building is 380 meters high. And what equation would you use to find the angle of elevation? So clearly this is our theta, which means this is the opposite because it's across from theta. This would be our hypotenuse because it's across from the right angle, but the hypotenuse is blank, so we don't need to worry about it. Since that was the hypotenuse, the only one left is adjacent. Since we're using opposite and adjacent, that means we're using tangent, which is opposite over adjacent. Tangent, opposite, adjacent, tangent, opposite, adjacent, tangent. So opposite was 380, adjacent is 83. Now, if you notice, x is not at the top, nor is it at the bottom, which means we're going to have to use the inverse to figure out x. So tangent inverse, you put the fraction, and then the x travels over there, and that's what we're going to put in our calculator. And we get 77.67. All right, and you know what? I was being extra. I'm so sorry, y'all. It said what equation? So honestly, we could have stopped right here. Okay, that was unexpected. All right, number 4 says a dog is standing 5 feet from the base of the tree looking up at a cat. So we're going to do angle of elevation, triangle, which looks like that. This would be our angle of elevation. This would be the height, which it said 16 feet up in a tree, and then the dog is 5 feet. So go ahead and solve or write the equation for this one. Number 5, which of the following could be the side lengths of the right triangle? Let's try it out. 9 squared plus 40 squared, and then we're going to compare that to 41 squared. So if you put 9 squared plus 40 squared in your calculator, you will get 1681. If you put 41 squared in your calculator, you also get 1681. So that is a right triangle. So I'm going to circle that one. Let's try another. I'll put it up here. 9 squared plus 12 squared, and we're going to see if that's equal to 15 squared. So 9 squared plus 12 squared goes in my calculator, and I get 225. 15 squared goes in my calculator. I get 225. They are equal, which means this is also a right triangle. Let's try the last one. 4 squared plus 5 squared, and we're going to compare that to 7 squared. If I put 4 squared plus 5 squared in my calculator, I will get 41. And if I put 7 squared in my calculator, I get 49. These are not equal, so that is not a right triangle. So the answer would be option 2 and option 1. I said that backwards, but option 1 and option 2. Go ahead and try number 6. You only have to do the a squared, b squared, c squared thing one time and then just tell if it's a right triangle or not. Number 7, what is the measure of angle A rounded to the nearest degree? So since it's asking for angle A, we're going to put theta in angle A. So since that's theta, that means this is opposite, and opposite was blank, so we don't really need to worry about that. Across from the right angle is always the hypotenuse, and the other one is always adjacent. So since we're using hypotenuse and adjacent, that would be cosine. Cosine, adjacent, hypotenuse, cosine, adjacent, hypotenuse, cosine, adjacent, hypotenuse, tangent. Sorry, I like the song. I know y'all don't like the song. All right, so since theta is unknown, I'm just going to put an x right there. And since x is not in the fraction, that means we have to use the inverse of cosine to figure that out. So in my calculator, I'm going to put cosine inverse. I'm not going to keep going back and forth between the calculator because I've already done it many times in addition to this video. We're rounding to the nearest degree. So since that says 0.5, we're going to round that to 47. When it says nearest degree, it means nearest whole number. Again, I know I keep telling you to round to the tens place, but if it's telling you to do something different, then do the thing that it's telling you to do. Oh, hold on. I made a mistake. In my calculator, I put 11 over 16 instead of 11 over 61, and so it gave me the wrong answer. So that should be 79.6, which rounds to 80 degrees. Apologies for that confusion. Make sure you fix it on yours. Go ahead and try number 8. So now we're trying to look for angle, sorry, that should say angle C, not angle B. So now we're looking for angle C, which means now this will be opposite and this will be hypotenuse because of course it's across from the 90-degree angle. So go ahead and try that one. Number 9, on the one end, of a 12-foot ladder, so this ladder is 12 feet, it's 5 feet from the base of the wall. How high, so we'll put the X on the height. How high does this ladder touch? And we're going to round to the nearest tenth. This should say 10th. All right, so since we don't know any angles for this problem, but we do know two sides, we're going to use Pythagorean theorem. And like I said before, let's see if we can figure out a shortcut. 12 is the hypotenuse. 5 I'm going to call B, and then X is going to be A. So since we don't know A, we're going to use the shortcut that's in your notes. A equals the square root of C squared minus B squared. So that's going to be 12 squared minus 5 squared. I'm going to put that in my calculator. So the let me just show you. Square root of 12 squared minus 5 squared, and that'll give me 10.9. All right, go ahead and try number 7. Let's say number 7, that was weird. Try number 10, and then let's go to number 11. A rescue helicopter pilot spots a stranded fishing boat. The angle of depression is 35 degrees. The altitude is 1800. What's the helicopter's approximate distance from the stranded boat? So again, distance is on the hypotenuse. This would be our theta, which means this is the opposite. Sine is the only one that uses opposite over hypotenuse. Sine, opposite hypotenuse, sine, opposite hypotenuse, sine, opposite hypotenuse, cosine. All right, so there we go. Since x is at the bottom, or in this case, d, we're going to divide. So the fraction number always goes first. All right, 1800 divided by sine 35 would give us 3,138, and we're rounding to the nearest whole number, so no decimals. After this was 0.2, so that's going to round to 3138 even. All right, oh, I did it again. So for this one, we just wanted the equation. So we would use this. All right, number 7. I'm sorry, why do I keep saying number 7? So weird. Number 12. All right, now let's look at number 13. What is the value of x in the triangle below? So this is, we don't see any angles that are marked, but we do see two sides that are marked congruent. If those two sides are congruent, that means this is an isosceles triangle. And hopefully you remember that an isosceles right triangle is also called a 45, 45, 90. So we're going to use 45, 45, 90 rules. The 45, 45, 90 rules state that if you do know the hypotenuse, which we do, the hypotenuse is given, then all you have to do is divide by the square root of 2, and that'll give you the length of the leg. And since this triangle is isosceles, both of the legs are going to be equal. So there is no short leg, long leg. Both of the legs are going to be equal. So we're going to take 16 square root of 2, and we're going to divide it by the square root of 2. So let's go do that. 16 square root of 2. Do not do this. You see that? How the square root of 2 is underneath the other square root? Do not do that. Absolutely not. Click to the right, then put divided by the square root of 2. So they will be separate, and then you get the correct answer, which is just 16. Go ahead and try number 14. Number 15. Given the right triangle below, determine the ratio for tangent B. B is going to be theta because that's the angle they want me to do. So that means this is the opposite. This is the hypotenuse. Oh, tan. We don't need that. Tangent is opposite, adjacent, tangent. So we just need the adjacent. We don't need the hypotenuse. So tangent B, or tangent theta, whatever helps you out there, is going to be opposite over adjacent. Now, be very careful. Some of you who are real smart might think that we have to do that to figure out the measure of theta. But did it tell you to do that? No, it said get the ratio. Ratio is just another word for fraction. So we're pretty much done, but we just need to simplify 9 over 12. So let's try to, so 9 over 12 simplifies to 3 over 4. And that's that. Number 9. Just kidding. Try number 16. Number 17, given the triangle below, calculate the length of the side labeled with X. So this is a 30, 60, 90 triangle. So we're going to use the 30, 60, 90 rules. All right. The 30, 60, 90 rules say that there's a short leg, there's a long leg, and then of course we have the hypotenuse. But we don't really need it for this problem because the X is on the long leg. So if you know the short leg, all you have to do is multiply that by the square root of 3, and that'll equal the long leg. So the short leg is 5. So we're just going to multiply that by the square root of 3. Now, you could put this in your calculator. It will give you a decimal. The answer choices on the test, however, are not in decimal form. So all you need to do is keep it just like this. Go ahead and try number 18. Number 19. Given the right triangle below, determine the length of the side labeled with X. So for this one, we see theta is right here. This is hypotenuse. This is adjacent. Hypotenuse and adjacent are the cosine ratio. So adjacent over hypotenuse. Cosine, adjacent, hypotenuse, cosine. So that's going to be cosine 42 equals adjacent, which is x, over hypotenuse, which is 12. When x is on top, we multiply. So 12 times cosine 42 is what we're going to put in the calculator. So we get 8.9. Go ahead and try number 20. Number 21, calculate the length of RT. Now this is a throwback. We call these spiraled in questions because it's stuff that we've done before. We're spiraling it back in. This is called a mid-segment. And the way that we do mid-segment equations is that we have to double the mid-segment, and it's going to equal the length of the parallel side, which is this one down here. So we're going to double this 4x plus 2, and that's going to equal 4x plus 44. And you know how to solve for x. You can use LinSolve or InSolve. I'm going to go ahead and solve this by hand just to give you some practice. All right, so we get x equals, looks like negative 12. That doesn't seem right. Hold on. Okay, let me double check. No, that's definitely not right. Okay, let me see where I made my mistake. 42, right, we doubled this, boom, boom. That's my mistake right there. So I put minus over here, and it was supposed to be plus. So that's going to be 8x plus 4 equals 4x plus 44. Then I can subtract the 4x. Then I can subtract the 4. And then we get to divide both sides by 4. And that would be x equals 10. Okay, that's better. And then it just wants us to calculate the length of RT. So since RT is 4x plus 44, we're just going to plug in a 10 right there. So that'll be 40 plus 44, which is 84. Number 22. Where can the perpendicular bisectors of the sides of an obtuse triangle intersect? Okay. You know what? I'm not doing this to myself. Hold on. I've already done this once. I don't feel like drawing it again. All right. So as you can see here, I've drawn an obtuse triangle. I've drawn 2 of the 3 perpendicular bisectors. All right, so we see that they are intersecting here outside of the triangle. And that's all.